Okay, this is the construction of the helium neon laser. So this is a partially reflecting mirror. This is totally reflecting mirror. This tube contains gas molecules helium plus neon, and this is a high tension battery. This is appropriate resistance R. This is key, and these this is the construction of the helium neon laser. So we know that every laser contains three main components. One is laser medium, which contains two parts: active medium plus supporting medium. So you can see it is here. So active medium is here neon, and supporting medium is here is helium. So both of these gases, these make laser medium. Okay, then we have second is optical resonator. So it contains one partially reflecting mirror and one totally reflecting mirror. So these two mirrors combinedly form optical resonator. And the third component of the laser is the pump. Here in this case we are having electric discharge pump. So it supplies energy for excitation. So as to produce and maintain population inversion. So this uh, these electrodes plus this battery plus key plus resistance along with discharge tube which is made from glass is making the pump along with discharge or glass tube is making pump. So in this diagram, therefore, you are clear about what is laser medium, and amongst laser medium, which one is active, which one is supporting. So acting is a neon and supporting medium is helium. I will tell you later on why it is so. So then we are having optical resonator, which contains partially reflecting and totally reflecting mirror. Then there is pump. It contains electrodes, battery, key, resistance along with the glass discharge tube. So I think everything is clear about the construction of the laser. So the first part which tells about what is the construction of the laser is okay. Let us now go to the next page. Okay, next page is about the working and theory of the helium neon laser. Working and theory of helium neon laser. So first of all, please remember these are the energy states of helium. So energy states of helium. So suppose this energy state is E1. So rather I would use the symbol as F1. Let us say this energy state is F2, this energy state is F3. Okay, what is more important to remember is that this state by default it is long lived. Similarly, this state by default is long lived. So it means when we excite helium atoms from F1 to F2 or from F1 to F3, then the helium atoms stay here for a long time. These atoms stay for long time and they will not prefer to come to the ground state earlier. So it will not be feasible for us to get light at a fast rate if we use helium only. So on the other hand, if I draw the energy level diagram of neon, so we have to remember it as such because it is the characteristic property of the molecules or atoms, you can say, because both of these gases are monoatomic. So the energy states of neon are, this one is E1, somewhere here we are having E2, this one is E1, this is somewhere here is E3, and somewhere here it is E4, then somewhere here is E5, and then E6. So it is just a coincidence that the energy difference E6 minus E1 of neon is approximately equal to the energy difference F3 minus F1 of helium. Similarly, energy difference F2 minus F1 of helium is approximately equal to energy difference E4 minus E1 of neon. Please remember, F1 is not equal to E1. Energy of F1 level is not equal to energy of E1 level. But for the sake of better understanding, I have shown these to be at same level. Similarly, for the sake of understanding, I have shown these to be at same level, these to be at same level. So absolutely F1 energy and E1 energy are not the same, but actually the difference, relative difference between the energy states is the same. So what is going to happen? Let us see now. If we start an electron from cathode, let us say this is cathode and this is anode in the discharge tube. So cathode emits electrons. So suppose this is an electron, and after emission this will move toward anode because cathode is given negative potential and anode is given positive potential. So let me go to the previous page. Okay, I have given positive in this side and negative in this side. So if I maintain one-to-one correspondence, so let me maintain that. So I will erase this. Therefore this will be cathode, it is given negative potential. This will be anode, it will be given positive potential. So between cathode and anode, these circles are gas molecules. I have not shown the discharge tube, kindly assume that it is there. And the cathode will emit electrons because of the potential difference applied by the external high tension battery, which is also called as accelerating potential. So this electron is traveling from cathode to anode. As it is going from cathode to anode, it will strike with the gas molecule. Due to collision, when the electron will collide with the gas molecule, then during the collision, the kinetic energy of the electron will be transferred to the gas molecule, and that energy, if it is equal to the energy difference between F1 and F2, will take the helium molecule from state F1 to state F2. Similarly, if that energy is equivalent, if this kinetic energy is equal to the difference between the energy of F1 and F3, then after collision, that gas molecule will transfer from F1 to F3. So similarly, F2 to F3. So kindly remember, only one electron is not emitted at a time. Many electrons are emitted at a time, and these are traveling from cathode to anode. Many electrons will just get wastage of their energy at the time of collision. The energy will be wasted. Energy wastage will take place whenever collision takes at a point when kinetic energy of electron is not equal to either the energy of F2 minus F1, or kinetic energy is not equal to the energy difference between F3 minus F1. So during that point, such type of collisions will just lead to the wastage of energy, and amount of heat will be produced. So that energy wastage will create the temperature of the tube to be high, so we have to cool it. So we can cool it by blowing air, so we can have air cooled, as well as sometimes if we have a helium neon laser of high power, then we can have liquid cooled helium neon lasers. Otherwise, air cooled helium neon lasers are mostly available in our physics lab. We have air cooled helium neon lasers, and these are of 2 milliwatt. In the physics lab of our college, we have helium neon laser of 3 milliwatt power. So we have these two types of lasers. One gives output of 2 milliwatt, other gives output of 3 milliwatt. So what happens when these electrons collide with the gas molecules? Then the gas molecules take this energy. Because these states are long lived, what happens with the time? With the time, more and more helium atoms go to states F1 or F2, and their number increases. Now let me tell you that helium and neon, I have to add a new page. So if there is any need, I will refer back to this page. So let me introduce a new page. So please remember, both helium and neon are monoatomic gases. Helium and neon, this is, let us say, helium, this bigger one is, let us say, neon. Both are monoatomic. It means they have only 3 degrees of freedom, and these 3 degrees of freedom can produce only translational motion, and the transitions can be electronic only. So what is the meaning of this? That when helium and neon, right now I am talking only about helium because I have not discussed what will happen to neon. When helium will go from state F1 to F2 or F1 to F3, then its kinetic energy will increase, and that kinetic energy will introduce translational motion. This will introduce randomness. So it means excited helium atoms are traveling with high speed. Then atoms with in ground state. So such helium atoms, if I show you previous slide, so suppose there is a helium atom which is in the excited state F3, so it is traveling with extra high velocity. So when it will, because the gas tube contains both kinds of atoms, helium also and neon also. So let me show, suppose these bigger circles are, let us say, of neon. So when an excited helium collides with neon, then there will be energy transfer, and that energy transfer at the time of collision will be this is a fundamental fact that whenever collision takes place at the atomic level or molecular level, then the energy transfer time is less than 10 raised to power minus 10 second. It is less than or equal to, most of the time it is this time. This is called atomic energy transfer time. So within this time the energy transfer will take place. So whenever helium will collide with neon, what will happen? Helium molecules will go to the ground state, and immediately any neon molecule which has collided with the helium, it will go to the state E6. Similarly, if there is a helium molecule in the state F2, it will go to the state, this state, which is E4. So this will create a population inversion, and because the time of collision is very small, so it is possible that within a small time most of the neon molecules or most of the helium molecules are in the excited states. Now what is interesting fact, these states of E6 or E4 of neon, these are short lived. So this is also short lived. So it was not possible for helium atoms to go directly to the ground state fastly, but indirectly they have collided with neon, and neon molecules will go to the ground level with a fast decay. So the fast decay is E6 to E4, then E6 to E5. So any molecule of neon which is in the state E6, it fastly decays either to state E5 or it decays to the state E3. Similarly, if a neon molecule is in the state E4, it will fastly decay to E4. We have to remember these. So these three decay are fast decay. So if a photon is released due to this decay, that is called E6 to E3, then such a decay will produce light photon in the visible range, and its wavelength will be 6328 angstrom. Similarly, this decay produces 3.39 micrometer 3.39 photons, which is not in the visible range. Similarly, this decay produces 1.15 micrometer photons, which is again not in the visible range. So in the visible range we have got only this transition. So if that photon is traveling, if I go to again previous slide, if this photon is now traveling within the discharge tube, then it will collide with another molecule of neon, and it will start producing. So this photon is, let us say, traveling like this, and it collides with the neon molecule. Then this neon molecule will decay because of stimulated emission, and the number of photons will become 2. 2 will then become 4. Then because of the action of the mirror, their number will start increasing, and as a result we will get a beam of light parallel to the axis of the helium neon laser discharge tube. So this will be the interesting part of this helium neon laser. Let us now remember that from here to here the transition takes place automatically through spontaneous emission. But what is the problem? This is a problem that the state E2 of neon, it is long lived. So because of that, the neon molecules which come here, they can start accumulating here. With time, the number of atoms in neon will start accumulating, and sometimes it can happen that these neon atoms may absorb the energy due to the electrons within the discharge tube. हाँ जी हेलो, हाँ जी बोलिए, हाँ बोलिए बोलिए। बेटा आपको मेल आ जाएगी, एमसीक्यू टाइप होगा, मेल आ जाएगी, उस मेल में एक लिंक होगा। हाँ वो करना है आपने, जो भी होमवर्क जो भी आपके न्यूमेरिकल बेस्ड होंगे उसका कैलकुलेशन पार्ट संभाल के रखना है, और उसको विद इन 1 आवर आपने अपलोड कर देना है। स्पीड पोस्ट करना है लास्ट पेपर वाले दिन, ठीक है? ओके जी, ओके। Okay students, now what will happen that this is a long lived state, so we have to bring from E2 to E1 forcefully. This is called induced de-excitation. This is called induced de-excitation. We have to do it. Agar if we do not perform this induced de-excitation process, then what will happen? The electrons which are traveling in the discharge tube, these electrons can collide with these neon molecules, and these neon molecules can absorb this energy, and these can go back to this state. When these will go back to this state, then the number of molecules here will start increasing, and you are seeing that the laser action is given by the states E6 and E3. So what is the problem? If the number of atoms in E3 is increasing, it will lead to the ceasing of the population inversion. So we have to avoid this. So we have to bring these atoms back to the ground state as early as possible. This process is called induced de-excitation, and we achieve this induced de-excitation process by using collisions of the neon molecules with the glass walls. So if we collide the glass walls, so collision of neon with glass walls will bring neon E2 to E1 forcefully. So this is what we have to take care, and as a result our the lasing action will continue, and we have continuous beam of light, continuous beam of light. So I will stop here now. If you have any question, you can ask me. So kindly remember, it is a 4-level laser. Helium neon laser is a 4-level laser. So if you have any question, you can ask me now by unmuting.